Are there any questions on any of the assignments so far? Our first 4 assignments. Any questions on 10.1, 10.2, 10.3, or 10.4? Now, the first thing we're looking at today is the tangent and intersected chord theorem. If a tangent and a chord intersect at a point on a circle, then the measure of an angle formed is 1/2 of the measure of the intercepted arc. So here, the measure of angle 1 is half the measure of arc AB. Or the measure of angle 2 is half the measure of arc ACB. That's it. Questions on this here? So if we look at this one here, we're told that the arc AB, so the measure of arc AB is 130 degrees. We want to find the measure of angle 1. So what would we need to do? Because the measure of our angle is half the measure of its intercepted arc. So here we're going to take 130 and times it by 1/2 or divide it by 2, because those are the same thing. So the measure of angle 1 is 65 degrees. And that's it. This will be part of the semester test, yes. I mean, it's going to be chapter 10. Because this is one section of the whole unit.
So will chapter 11 be a semester?
This is the semester test.
Like all the
10.5 will be one part of the whole chapter. Okay. And scroll. The measure of angle L. Well, so everything we've done so far and what we're going to do will all be there. So it's not just going to be this. So they told us that this angle here is 125 degrees. We want to find the measure of arc LJK. Well, the angle is equal to half the measure of the arc, so the arc is equal to what? Twice the measure. Because what we're saying is that half the measure of LJK is equal to 125. That's essentially what we're saying by the formula, because the angle is equal to half the measure of the arc. So we're saying half the measure of the arc is equal to 125. Well, instead of saying half, well, we can take this and multiply it by 2. So the measure of LJK is 250 degrees. Questions on this here? Are you ready for the next one? Yeah, we would take 240 and multiply it by 1/2 or divide it by 2, which tells us that the measure of angle 1 is 120 degrees. And that's it. Questions on this here? LJK, measure of arc LJK would be 155 times 2. Two times 5 is 10, so 0 carry the 1. 2 times 5 is 10, plus 1 is 11, so 1 carry the 1. 2 times 1 is 2, plus 1 is 3, so it would be 310 degrees. Well, that makes sense because we almost have the entire circle. And the entire circle would be, what? 360. Questions on this here? Do we feel comfortable with these here? Okay. We will move on. Intersecting lines in a circle or on a circle. Two non-parallel lines intersect a circle. There are 3 places where the lines can intersect. One of them is intersects on the circle. The second is inside of the circle, and the third is outside the circle. If we draw 2 lines intersecting a circle, the 2 lines will either intersect on the circle, in the circle, or outside. That's the only way we can set these up. And we have different theorems that come from it. Now, if the 2 lines intersect inside the circle, the measure of angle 1, the measure of this angle, is equal to half the sum of the 2 arcs. Equals half the sum of the 2 arcs. If they intersect inside the circle, it's going to be, the measure of this angle is equal to half the sum of these 2 arcs here. Well, same is going to be true for that angle there. Because those 2 angles, one and the other one I just drew in green, are vertical angles. And vertical angles are congruent. Those are going to be the same. Angle 2 would be the sum, half the sum of these 2 arcs. Questions on this here? Now the other case that we have is outside the circle. And outside the circle, the angle is equal to half of the measure of the bigger arc minus the smaller. Half of the measure of the bigger arc minus the smaller. Bigger, smaller, bigger, smaller, bigger, smaller. No matter how we have this set up, the measure of our angle, the one outside the circle, is equal to half of the bigger minus the smaller. Questions on this here? In this here, using this kind of formula is actually how the Greeks were able to figure out the circumference of the earth. They were off by like 5%. Which is actually very good. So we have these 2 here. Now, how many different setups did we have for 2 lines intersecting a circle? 3, or yes? How many did we just cover? Oh wait, what was the third? It intersects on the circle, yes? Well, actually, we covered that the other day. Because this is our circumscribed angle, because an angle on the circle is equal to half the measure of its arc. We already did this. So the other 2 are the ones that we're really focused on at this point. Now, when we look at this one here, the 2 lines intersect inside the circle, yes? So we know that the measure of x, this angle here, is equal to half, because both of these formulas, the angle is equal to half either the sum or the difference. Well, here, are we going to add or subtract? Whenever we're inside, we add. Whenever the angle is outside, we subtract. So here we're going to add its 2 arcs. So one of them would be, and the other is, well, the first thing we can do is add 156 and 130. Then we can multiply it by 1/2 or divide it by 2 and get 143. What actually works out this angle over here is also And that's it. Questions on this here? Are you ready for the next one? Yeah, so here we have the angle outside is equal to half bigger minus the smaller. So the bigger is 178 and the smaller is 76. So it's the bigger arc minus the smaller. So here the bigger arc is 178, the smaller arc is 76. Now at this point here, we could type this entire thing into the calculator because 1/2, 178, and 76 are all numbers. That's just numbers on that side. The variable is not over there. Or we can do it in parts because we can do 178 minus 76 and get 102. And half of 102 is, and that'd be it. And again, with either one of these formulas, we're just plugging the values in and solving for x. Any questions on any of this here? We ready for the next one? Huh? Right? Because the two lines intersect inside the circle, yes? Now we want to find the measure of x, this arc, yes? And we are also given this arc here, yes? Now I know if I add those two together, we're going to get what angle? Is it the 94? No. We're going to get this here because the formula, the angle inside the arc that we get is one of the ones that connects to the arc itself. So we'd actually get this angle here. Because this angle is equal to half of x plus 80. But what is that red angle? Do we have it? Well, we know the angle next to it's 94, yes? Two angles that make a straight line do what? Add up to be 180, yes? So if I wanted to find this red angle, we can take 180 and minus 94 from it. Seven, 6. So this angle here is 86. So 86 is equal to 1/2 of x plus 80. So here we had to find that angle first. Any questions on how we found 86 or have set this problem up? What can we do next? All right, we can distribute. So we can multiply 1/2 through. 1/2 times x is 1/2 x. 1/2 times 80. 40. Half of 80 is 40. Now what can we do next in solving for x? Getting x by itself. We can subtract 40 from both sides. And we subtract 40 from both sides. 40 minus 40 is 0, giving us 1/2 x. 86 minus 40 is 46. Last but not least, what can we do? We can divide by 1/2 or by 2. We can flip it because we can multiply by the reciprocal because 1/2 times 2 is 1. These simplify to 1. So that means over here we're going to multiply by 2, telling us x is equal to 92. And that's it. Now, if we wanted to, we could have multiplied by 2 at the beginning and solved it from there and gotten the same answer. Any questions on this here? All right, let's look at the next one. Is this going to be addition or subtraction? Because the angle's outside. The intersection of these two lines is outside the circle. So how would we set this up? So the bigger angle is 100. The smaller arc is x, because again, the ones that go inside the parentheses with the 1/2 are our arc measures. What goes on the other side of the equal sign? 35. Because that extra angle is equal to 1/2 of the bigger minus the smaller arc. What can we do next? We can distribute the 1/2. So over here we'll still have 35. 1/2 of 100, or 100 divided by 2 is 50. Minus 1/2 times x is, what do we do next? Minus 50 from both sides. So again, we're trying to get x by itself. So here 50 minus 50 is 0, leaving us with negative 1/2 x. 35 minus 50 is negative 15. What do we do next? Right, we can divide or multiply by not just 2, negative 2. Because since it's negative 1/2, we want negative 2, or we can divide by negative 1/2. Here, these will cancel out, giving us x by itself. Yes. Because the negative and negative would make a positive. 2 times 15 is 30. Questions on this here? Any questions on anything we've done so far? This is kind of like one of the ones we've done already, yes? Now they tell us that one angle is 102, but 102 really doesn't help us to find y. Because to find y, we need this angle here, not the 102. And exactly, to find out the angle we need, we can take 180 and subtract 102 from it. Because again, any two angles that make a straight line add together to be 180. And 180 minus 102 is 78 degrees. So the angle that we need is 78. So how would we set this problem up? Almost. So we'd have y plus 95. Because again, for this one here, the internal angle is equal to half of the sum of our two arcs. Any questions on this so far? Any question on anything we've done so far? Let's do this one a little bit different. Let's multiply both sides by 2 first. Because if I multiply both sides by 2, 78 times 2 is 156. Here the 2 and 1/2 will simplify to 1. So that tells us 156 is equal to what? What can we do next? Minus 95 from both sides, telling us y is 61 degrees. So sometimes multiplying by 2 first makes it a little bit easier. Because here, if we had multiplied by 1/2, well, we would have 1/2 y, and 95 does not divide by 2 evenly. It would be, what was that, 42.5? No, 47.5. So it's not a whole number. It will work out to be a whole number, just not at this point here. Any questions on any of this so far? Let's look at this one. I think this is, we got 2 more left? No. No, we've got a few more. Any other questions on these here before we move on? Or do we feel comfortable with these? All right, circumscribed angle. A circumscribed angle is an angle whose sides are tangent to a circle. The measure of a circumscribed angle is equal to 180 minus the measure of the central angle. They're saying that this angle out here is equal to 180 minus this one here. Because these two angles are going to add together to be 180. We know that in a four-sided figure, as this has 1, 2, 3, 4, the sum of all the angles is 360. Now, because these are circumcised or tangent to the radius, it means these two angles have to be 90. Whenever we have a tangent line and a radius, they've intersected a right angle. So it's telling us that two of these angles are 90. This is 90 and this is 90. Well, if they all add together to be 360, well, 90 plus 90 is. And if we subtract 180 from 360, we get. So the circumscribed angle and the central angle have to add together to be 180. That's just by definition. So we look at this here. This angle x and 135 have to add together to be 180. So we can subtract 135 from 180, which would give us, so x is equal to 45 degrees. And that's it. Questions on this here? We good with this here? All right. Now, is angle x a central angle? No. Exactly. Now, if we had this angle here, then we would know for sure that this is 160, yes? Well, that is helpful because the central angle and its arc have what? The same measure, yes? So what's the measure of arc EF? 160 degrees, yes? Any questions on what we just did? Because we know that this angle, circumscribed angle, and the central angle add together to be 180. Because our circumscribed angle, the measure of the circumscribed angle is equal to 180 minus the central. Now this one here, they didn't give us the central angle. Angle x is not the central angle. But So this and the central angle do. Yes. Or, sorry. Thank you. I don't know where I got 160 from. 150. Sorry. So these here should be 150. Does that make more sense now? Okay. Now we know that the measure of arc EF is 150 because it's the same as the central angle, which we liked. I think that was in 10.2. Central angle is going to be the same as the arc, and the arc is the same as the central angle. Well, now I was kind of wondering, why is this helpful? I'm going to remove these. Move those over there. No. I'm just going to erase one. So using that, we could find that arc, yes? Well, the measure of angle x is a inscribed angle. The vertex is on the circle, yes? What do we know about it and its arc? It is equal to half the measure of its arc. Well, half of 150 is? So this one here, we had to use our formula for central angle to find that arc, to then find the inscribed angle. So we had to take a few steps to get there. Questions on this here? We'll get to another one of these here. Oh, we'll look at this one here first. Because 124 is a central angle, its vertex is on the center of the circle. So we know x and 124 add together to be 180. So we can subtract 124 from 180, telling us x is 56. Questions on this here? Right, because 180 minus 42 would give us the central angle. So our central angle would be 180 minus 42. 138. So this is 138 degrees, which we know means that this arc has to be 138 degrees. And the angle we want, x, is equal to half the measure of its arc, which is, and half of 138 is 69. And that's it. Questions on this here? X is, as here we're doing 180 minus 120, which is 60. Questions on this here? Right, so we would do 180 minus 50, which would be 130. That's our central angle and this arc. And then we can say x is equal to half of 130. So x is and that's it. I don't think this is on the note sheet, but we'll look at this one anyways. Now, if we're going purely based off the formula, we know that the external angle is equal to 1/2 of the bigger arc minus the smaller. So what would FH be? Well, 15x goes from here to here. 45 is this one down here. Now, if we had the center, this here would be a central angle, yes? So what do I know about the central angle? It and 45 do what? So this here would be. So actually, what's the measure of that arc? So the smaller arc is? We can. I would go there. And the reason I would do that is because looking at this here, is 15 and 135 divisible by 2? Can we divide both of those by 2? No. Then let's just multiply. Because these will cancel. 45 times 2 is equal to add 135 to both sides. And then we would divide both sides by 15. So 75, not 13. Would be the answer. Questions on this here? Now, we can look at this another way. Because the exterior angle is 45, yes? Now, the bigger arc is 15x. We already said that because we can see that there. Minus, what's the whole circle? Because we can set it up like this here. Because if the whole circle is 360 and I take away from it the bigger arc, I will have the smaller. There's another way we can look at this. And we would still need the 1/2. Now it looks like 15x minus negative 15x. If we distribute that negative, it would be 15x minus 300 plus 15x, because the negative and negative would make a positive. Now, for this here, 15x plus 15x is, and that should be 360, 30. Okay, we can actually multiply this by 1/2, because half of 30x is minus 180. Now at this point here, we can add 80 to both sides, telling us 15x is equal to same thing, just a different way to get to it. And that's it.